Good day, amazing scientists. It's a favorite sensei here again, Sensei Memo, and hope you are doing good. On today's lesson, we are gonna be dealing with functions. We are gonna be dealing with derivatives and also how to find the value of k whenever you are given k as a constant and you need to find the values of k. We'll be using discriminant. So if you are new to the family, please make sure you press the subscribe button down there below and be a part of our family. Don't forget also to share the video as much as you can to your friends, to your neighbors, and tell them that the sensei is back with a fresh new lesson. And yeah, without any further ado, let's just start the work. So the question it says, so this is a past paper from Eastern Cape, September 2022. So the diagram below shows the graph of f of x, which is x squared, which is the parabola, which is this parabola, x squared minus 4x minus 11, and x squared minus 4x, okay, minus 11, and f of x with g of x, which is the derivative of f of x. And so this straight line graph, the equation of the graph is found by doing the derivative of this graph. For x-intercepts are a and b. So a and b are x-intercepts of the parabola, and c is the x-intercept of g. D is the turning point here, the turning point of graph f, the parabola, and these two graphs intersect at m, which is here, and n here. So here we're given m equals to -1 and t, so we're not given the y value here, but it will be easy for us to find it. And also we are given also values of n, coordinate 7n is to 10. So the first question says to us, find the coordinates of b, which is the turning point of this graph. So remember, turning point, turning points, we are minus 2 minus b over 2a, which is minus, into minus 4 over 2 into 1, which is 4 over 2, which is 2. So which is for the x value, and the y value, we substitute this 2 into the normal equation, f of 2, which is 2 squared minus 4 into 2 minus 11, this is 4 minus 8 minus 11, sorry for that, which is minus 4 minus 11, which is going to give us negative 15. So we have the values, which is negative 2 and 15. Let's just check using calculator just to make sure that we didn't do any mistakes there. Minus 2 minus 4 into 2. Yes, good. We didn't do any mistakes. So d, it's negative 2 is to, positive 2, positive 2 is to negative 15. So let's find the distance of Cn. So Cn. So it's very crucial for us to find first, before doing this, to find first the point of C. So how do you find the point of C? Remember, C is the x-intercept, and C and D, they have the same x value. Even though they didn't prove it there, but then let's just test if they have the same value. Let's just not do any speculation. So we need to first find the graph of G, which is the derivative of f. So we know that it was 2. We'll be using this rule of derivation, 2 times 1x 2 minus 1. Remember, it's the exponent multiplied by the coefficient. So minus 1 minus 4 times 1 and 1 over 1. Okay, so this one will just disappear because of it will be 0. So okay, it's 2x minus 4. So since it's 2x minus 4, this is the graph of g of x. So this is a parabola graph. So this is a straight line graph. So it's like this. So now, if now we have this, we wanted the x-intercepts. We know that y will be equals to 0. So for x-intercepts, so firstly let's just erase here. X-intercept, we're looking for c. X-intercept y equals to 0. So it's 0 equals to 2x minus 4. Take minus 4 to the other side, it will be 2x. So x will be equals to 2. So yes, they have the same x value. So now we know that c, it's 2 is to 0. So this and this, they have the same x value. So it can be easy for us to even find the gradient between or the distance between these 2 points here. So since now we have the coordinates of c, the coordinates of n are 7 is to 10. So let's just put it here. It's gonna be negative. Okay, let's just do it like this one. To the power 2, remember this is that's the general equation, yn, so minus yc squared. So it's gonna be okay, xn, n is 7, minus 2 to the power 2 plus 0 and 10. So 10 minus 0 squared. Then we will have 5 to the power 2, which is 25, plus 10 to the power 2, which is 100. So we will have 25 plus 100, which is 125. So the root of 125. So let's just use a calculator. It will be 25 times 5, which is 5 to the root 5. Let's just check. Yes, it's 5 to the root 5. So therefore now the distance of Cn is 5 to the root 5 units. So remember that firstly, even though we know how to find the distance using the distance formula, we have to first calculate or find first the coordinates of C, because of we were not given any coordinates of C. So now let's move to the next question, 1.2. So 11.2, sorry, 11.2.1. okay. Calculate for which values of x is f of x greater than g of x. So now we need points whereby f of x is greater, sorry, g of x is greater than f of x. So which means now we will be doing it this way. We'll be using the graph. So a point where f of x is higher, it's on a higher state, and g of x is higher and f of x is lower. So f of x is lower. So let's look for this point here. So try to check here. This point, okay, whereby g of x is greater than. So now this point here, f of x is greater than this one, and also this point here. Why? Because of this graph here. If we try to find the values, let's say for example the values of x here, let's say probably whereby x is 10, and we try to use the graph of f of x, we will find values that are higher, and then whenever we try to do this values of g, whereby g of 10, let's just check, okay? 10 to the power 2. So here on f of x, whereby x is 10, y is equals to 49. But here, using this graph where x is 10, y will be equals to 60. Yeah? So y will be equals to 60. So you can see now this graph of f, it keeps increasing higher, but the graph of g will not increase very high. So now we are looking for points whereby g of x is greater than, or let's just say f of x is less than. So it will be at this point wherever, so here f of x is greater, so here f of x is lesser. Why? Because of now the values of this graph A, of this, from this point till this point. Why? The value of this parabola, the graph of the parabola, it's lower. So hence why here, if we try to say values of c, for example, c, it gives us x is equals to 2, and then y equals to 0. But when it comes to g, it's 2, yes, but it's negative 15. Why negative? Because of it's lower, it's all on this Cartesian plane, it's at the lowest point. Meanwhile, this one is at the highest point. So hence why this point from here till here, it's a point in the graph whereby f of x is lesser, lesser than g of x, which means that g of x is greater, so it's where, remember again, it's here, from here, the point of intersection till that other side. So since so it's from m till n, in between m and n. So we looking for the x values. So it's gonna be from 7, just xe, from 7 till, oh sorry, from negative 1, sorry, from negative 1, since m is negative 1, from negative 1 till 7. Some of you can do it like this: x is less than 7, less than this one, since it will be lesser than this one, which is from 7, 6, 5, 4, 3, 2, 1, and negative 1. And it must be greater than negative 1. So greater than negative 1, because of it must go above negative 1, which means from negative 1, 0, 1, 2, 3. So which means that it's negative 1, 0, 1, 2, 3, 4, 5, 6, 7. So these are the values setting. These are the values of whereby g of x is greater than f of x. So now let's try looking for the second one here. Let's erase. So number 2, g of x minus f of x is a maximum. So now here, since they are looking for the maximum point, remember in calculus, whenever we're looking for the maximum or minimum points, usually these are the turning points. So how do you find the turning point equation? By doing the derivative. By doing the derivative. So now, so here, they are looking for the maximum point of these two graphs, g of x subtracted by f of x. So which means for us, we will be doing this. We'll be taking this graph of f of x, which is 2 and negative 4 minus x squared. We'll be just doing it the same way that they did here. So x squared minus 4x minus 11 minus 11. So now here we are gonna find a common graph or an equation from this. We're gonna derive equation. Sorry, not derive. We're gonna form a new equation from this. Then after that, we're gonna find the first derivative of that new equation. So which means we find new equation. Yeah? We're gonna find the new equation. Let me just use red. Okay. So you're gonna find a new equation. So now here it's x squared minus 2x. It's 2x minus 4x minus x squared and plus 4x plus 11. Okay. So it's negative. Let's just put it in this. Okay, let me just erase this. So x squared, negative x squared, and like terms, this and this, it's 6x plus 6x, and let's just use a different color for this. It's 11 minus 4, it's 7. Ne? So it's positive 7. So this is our new equation. Ne? So we need to find a derivative of this new equation. So it's minus, okay, it's n minus 1. So which is, it's 2 multiplied by negative 1 x 2 minus 1 plus 6. Ne? Since this one is just going to be 6 x 1 minus 1. Ne? So you know that let's just name it y. So y equals to negative 2x plus 6. Ne? So we have formed a new equation from this. Ne? So since we'll be looking for the maximum point, let's just find the x values of the maximum point. So now we know that for the maximum point is the x-intercept tangent. So this will be now equals to 0, because of it's the maximum point. Ne? Minus 2x plus 6. Let's just take let's just take 6 to the other side, negative 6, and 2 divided by both sides by negative 2. Therefore our x will be 3. So this is the maximum point. Maximum point. So remember now, this is the x value of the maximum point. So now let's move to the next question. It is here. Question 3. Yeah? Determine the average gradient between points of x, 2 and 7. So now, which is points of 2, which is we have to find 2 and 7. We have to find the values of y. Remember, for us to find the gradient between that point, we need to find, we're gonna use this rule, delta y over delta x, which is y2 minus y1 over x2 minus x1. So we need to find the y values of this. So it's substitute 2 into this equation. The f of 2 would be this minus 4 of 2 minus 11. So this is going to be negative 15, since it's the point D. Yeah? So of 7, also now they want the points or the gradient between these 2 points here. Let's just between these 2 points here. Yeah? So of 7. Okay, it's 10. So we definitely have been given the x value, sorry, the y values, you know? So we just have to, okay, so let's just say it's n here, 7 is to 10, and it's d here, -2, so the +2 and 50. So let's just find the gradient, easy. So it's 10 minus 50, so negative into -50. So here it's 7 minus 2. So here it's gonna be positive, so it's 10 negative into -50, which is 25 over 5. Our gradient will be 5. Okay? So now 111.4 determine the values of k, for which k will give us 2 roots with different signs. So now, since we're looking for the values of k, remember k is a constant, so whereby we have to add this constant to this quadratic equation, x squared minus 4x minus 11, to a point whereby whenever this value of k, if we add it and we find the roots, we will have 2 signs that are different. Ne? So we will be doing it like this. So we need to find the discriminant. Ne? So now here we have to find the discriminant of this point. So now remember, now this will be our a. So this is b squared minus 4ac. So remember that our discriminants here will be real roots. So it's, let's say for example, let's just put this here, and x plus 4. We know that let's say for example x squared plus 4 minus 1, so let's say it's plus 3 and minus 4. So now let's say it's like this now. So we know that whenever we do that, remember the roots are basically the x-intercept. So which means the x-intercept must be another number is positive and another one is negative. So basically here we're trying to prove which are these numbers. Let's say probably we add it here. This number, constant number that we will add here, it will make sure that whenever we factorize, we will find roots that are negative and positive, different roots with different signs. Ne? So let's just erase here and just attempt it. Ne? So now it's A and B and C. Now C, it will be everything that is inside here, this block. Yeah. So it's b squared, which is -4 squared minus 4a, and c is the whole thing. Remember, like I said, minus 11 plus k. Ne? So now let's just erase here the side. So it's delta is equals to b squared, which is 16 minus 4 minus 4 times -11 plus k. So this one will be -44 plus negative k, so -4k, -4k. So now here this will be 16. So now this and this are like terms, they will subtract each other out. So it's 16 minus 4, it's 38. So -38 minus 4k. So remember, because of the reason why it's equals to 0, it's because we're looking for these values. So that's why it's equated to a 0. Whereby we will check it must be an answer that is either greater than 0 or negative 0. Yeah. So now it will be 38 plus 4. Okay, this I didn't mistake here. It's negative and negative will give us positive. Sorry. So 16 plus 44, it's 60. Yeah. So it's 60. Let's just take negative 60 to the other side. Negative 4. Okay. It will be divided by 4. Divided by 4. Let's just use a calculator to find the value of k. So 60 divided by 4, it's 50. So now k will be 50. Ne? So which means, let's say for example, ne? Let's just apply it. Ne? K will be 50. Now we found the value of k, that is 50. So but then now we know that our values must be greater than 50. Why? Because if we try to use this 15, ne, it's gonna be, let's say for example, let's just make an example, it must be greater than 15, because of if there, let's say for example, if we know that if this is equals to 0, it will be roots, ne, that are equal, roots that are roots that have the same angles, ne, sorry, not same angles, sorry, same signs. Roots that have the same signs, ne? Which is usually they are like the same roots. Let's say probably it may be something like this, ne? To the power 2, ne? You know that negative 2, that it's the same negative half, it's like they are the same roots, ne? So now let's try to make it 15, and we'll also try to make it more than 15, just so I can explain this so you can understand. So it's gonna be negative 4x minus 11 plus 15. So it will be 4x and 4. So positive 4. So we will be using this. Ne? Check here now. The roots will have, both of them will be x equals to 2. Ne? Both of them will be x equals to 2. Why? Because of now, the values are the same. Ne? They have the same signs, but we're looking for values that don't have the same sign. So hence why it must not be 15, but it must be greater than 15. Ne? Let's just erase here and here and here. And let's try with 16, ne? 11 plus 16. So it will be x squared minus 4x plus 5, which you know it will be negative 1, and positive and negative 5, which we know that it will be x equals to negative 1, and the other one is positive 5. Ne? Because we're looking for roots that have different signs, so it must be greater than this value that we found here. So it was very nice doing this lesson with you, and I hope you enjoyed the lesson too. Don't forget to like, to share the video, to subscribe, and to press that like button, and also comment in the comment section. So from me, your favorite sensei, it's a wrap, and we're signing out. Peace and love. We are. Bye bye. Enjoy the rest of the video.